Welcome, friends. Today we are going to study one IEEE transition paper based on the power system. The title is Optimal Dynamic Pricing for Trading of User Utility and Operator Profit in Smart Grid. Basically, this project is into the power electronic systems, wherein we are trying to find the optimal pricing, and uh, main goal of this project will be to increase the profit of HGO, that is the operator, by optimizing various functions. So this is the triple transition paper. This is the main three-tier architecture system for our project. So this is at the core, like energy producer will produce the energy. This HGO, that is operators, will purchase the energy from energy producer, and then it will be provided to the user, that is third tier. So there are two communication, electrical communication and formal data communication lines presented. So user will send the demand to the HGO. HGO will purchase the energy according as per the demand from the energy producer, and it will be supplied to the user. This is how it will be working. So in this three-tier architecture, there are various utility and all. So for a demonstration purpose, we have simulated this project in the MATLAB simulation. This table one represent all the notations, wherein WIT represent the user preference time for the time slot T. DIT is user demand. Then DT is the total power demand of all users at time slot T. XIT is allocated power. WXIT, sorry, UXIT WIT is users utility at the time slot T. ST is the selling price of SGO to users. CJT is per unit power purchased by cost by SGO. YJT is purchased from producer. AJT is the available power of producer J. PSGO is overall profit of SGO at time slot T. PXP, that is expected profit of SGO. New it is an SGO power utilization efficiency. So also along with that, to find out the optimal optimization function, we had used ANN model over here, in which we are going to optimize this function. So this is the optimal power allocation algorithm, in which we are giving input as CJT, AJT, DIT, as we have discussed. CJT is power purchase cost. AJT is the available power. DIT is the user demand at that particular time slot. So after executing this optimal power allocation algorithm, will get the output as three parameter: YJT, ST, and XIT. Whereas YJT is purchase power from producer, ST is the selling price, optimized selling price, what we can say, and XIT is the allocated power to the users. So this is the algorithm. We can see the execution of algorithm. So here they had mentioned that for each time slot T, SGO will collect the CJT and AJT from each producer, energy producer J and M. So based on that, it will compute the optimal selling price ST and power purchase amount YJT from EPs by optimizing function 9. The function 9 is an objective function of our project. So I'll show you the objective function. So this is the equation 9, which is our objective function, where O is equal to summation of U XIT WIT plus XIT into ST from I is equal to 1 to n, minus summation of CJT into YJT from J is equal to 1 to m. This is the main objective function of our project, whereas there are some constraints that XIT should be greater than 0 and less than DIT. This is the main constraint it is mentioned. Second constraint, that is a power budget constraint. It should be that is summation of XIT should be less than or equal to YJT. Profit constraint ST should be greater than YJT into CJ, summation of YJT into CJT divided by summation of YJT. Then power purchase constraint, that is YJT should be greater than or equal to 0 and it should be less than AJT. So this is how it is interpreted. So we'll see certain example. I'll show a thesis for that. Herein, all the equation and everything is interpreted. So we'll see illustration. Like we have taken two cases. So case number one, that is over provision. That means based on the user demand, we have done the over provision of the parameter. So we have taken this parameter over here. So we have considered this five provider and whose values AJT, CJT, and WIT is like this based on given as per this table. Here we are taking initial selling price as per the paper, that is ST is equal to 4.756 and user demand for over provisioning. This is the DIT and XIT value. So we are taking this array as an input. As a result, our program will find out this output, that is predicted demand from the base, and it will find out this total calculation like total purchase amount, total actual demand, total utility demand, etc. So as like that, we have taken two cases: over provision and under provision. For under provision, parameters are like this, and this DIT XIT is like this. So in over provision and under provision, the main difference is that you can see here clearly that in over provision, DIT and XIT is equal. That means user demand and allocated power is equal. That means over provision. Because we had an over provision, we can allocate as much power as user has whatever the user demands, we can allocate the power because we had an over provision with us. Now in under provision, we can see that DIT is greater than XIT because DIT, that means user demand, is greater than allocated power. So based on that, our system will calculate the various results. So we'll come to see our code. Here we have designed two MATLAB programs. One that is for over provision, and this is for under provision. So we'll run one by one. First, we'll see over provision scenario, wherein as per the project scenario, we have taken a data set for various users. In that, like we are given input as an demand of the each user. So we can see one data set. These are the total 10 users we had considered for a illustration purpose. So we'll see number one, house number one, what is the demand for that. So this is the demand value and number of day of a month. So we have considered the 1 month scenario, that is 30 days scenario, and every day what is the total demand user has. This is specified by this column. It is KW. This demand is in KW. So you can see various KW demands in the data set. As like that, we have created 10 users and their 30 days demand. So this data set is given to our system. This data set will be utilized by our system to calculate various results and analysis. So we are taking this data sets over here, and afterwards our system will print the result. Again, as per the over provision, we have to take three input, that is CJT, AJT, and like we'll see the we have to take CJT, AJT, and DIT. So these parameters were given like CJT, AJT, and DIT. We have taken all the values from paper as it is, like what are the values are mentioned in the paper. Again, we have described YJT, XIT, then initial selling price, that is 4.756, which I had highlighted earlier. And based on that, our system will execute the optimal power allocation algorithm. So in this project, we have resolved all the equation mentioned in the paper. Like first, that is as per the paper, we'll see. So in this paper, it is given that first we have to find out the optimal selling price ST by equation number 9. So this is the main function, like function ST, which will find out the optimal selling price based on the CJT, AJT, DIT, and it will give you out the output as a XIT, ST, and YJT. So we are finding this function. So if you open this function, you can see the code for that function. this is the main function wherein we can see all the equation. The equation number 1 as per the paper, equation number 7 as per the paper, equation number 9 as per the paper. So based on this we can see various results graph and all. Okay, so you can see various equation as per the paper. I'll show one by one. uh, from here equation started. So you can see equation 1 for WIT, that is DIT divided by DT. You can see that equation WIT here. You can see various equation like say equation number 7, the UXIT WIT. It is resolved here. Equation number 7 as per the paper. You can see this is equation number 7. UIT of XIT WIT, that means user utility function. Next equation is equation number 9, our main objective function, which is we had seen just now. This is our main objective function. So it is resolved here. Afterwards, it will give you the ST. Then we are resolving equation number 3.2, that is function DT, that is power, total power demand. Then we are finding the function YJT. YJT is the purchase power. So based on that, we are finding further loops. So as per our paper, we'll see our optimal power allocation. So we have to compare whether dt is greater than summation of YJT. If it is so, then H to execute the sub function optimization from equation 40 and allocate XIT to all user. So we had already executed that, and we will allocate that power to the DIT to the user. So if that condition is not satisfied, then they are given further that if it is not satisfied, then it will find out next function, that is to find out the power wastage scenario, or to find out the next equation based on the further, that is equation number O1 is given in this scenario. So we'll see equation number O1 here. Let's see. This is the equation number O1, which will find out the O1's value by summation of U XIT WIT, whereas other constant is given, that is XIT should be greater than or equal to 0 and should be less than or equal to DT. So likewise, we are finding the solution. So once solution is given, that is O1 will retrieve. Based on that, it will retrieve the optimized selling price, which is printed in the console. This optimized selling price and XIT, that means allocated power to the user, is given to neural network. This is our neural network code. In that, like we are passing various things, that is learning rate, desired error, hidden layer, number of hidden layers we have taken 5 as a hidden layer, and all these things were given to the this neural network. We had used feed forward backpropagation artificial neural network for this. This is the code for feed forward artificial neural network, which is executing the uh, function, and based on that, it is finding as a predicted demand. We are finding the prediction thing. So this will predict the demand, and this demand is printed as a predicted demand. So based on that, we are finding various cost values as per the paper, like total actual demand, total purchase power. We'll see the result scenario one by one. And as I've shown you, we have taken this equation for overprovision. scenario as overprovision. We have taken AJT, CJT, YJT value and DIT, XIT. Now we want to find out the predicted demand. So first of all, I'll run the project to see the outcome. Here I'll run the project. So I had clicked on run button for the main.m, which is over provision scenario, and it will find out the result as soon as possible. So my system is calculating the various things. So it is showing various graphs. I will explain all the graph once all the graph is plotted. Till then we have to wait. So in this project we have used MATLAB as a simulation tool, and we have utilized some data sets for the validation purpose and all. So our project implementation is done, and it has printed all the results. So we'll see one by one all the results over here. So this is how system is executing. So this is first what we have taken at the optimized selling price. So as per the paper, we are given optimized initial selling price, that is 4.756. But after the optimization, our function had find out that optimized level, that is 5.8675. That is our optimum. This is the predicted demand. As per the paper, we can see this predicted demand is given here. This predicted demand column is given. So we have also printed our predicted demand here. So afterwards, our console is printing total actual demand, that is 3.8110. We'll see the exact value of the paper. This is total actual demand at 3.815. It is very similar to the given demand. Then to power purchase amount, that is purchase amount, that is 3.85, sorry, 825. So as per the paper, it is 3.825. It is same. Then we have to find out the total utility provided. Here in this case, it is 10. So in our case, it is also 10. So now we'll find out further thing. So there are certain result parameter, that is performance matrix is given in this paper. In this performance matrix, we have to find out various things like utility, that is U, by using equation number 4.1. Then profit of total profit, that is P total, that is summation of PHO. Then power utilization efficiency, nu, and profit ratio. These four are performance matrix were set by the paper. This equation are present over here. So we have calculated all these performance matrix value based on the same. So total profit is 5.076 into e raised to 3. Profit ratio, that is 0.9906. Power utilization efficiency, that is 0.8793. In this thing, like you can see, the constraint also matched. Like power utilization efficiency should be maximum 1, and profit ratio should be maximum, like it should be from 0 to 1. So all the things were satisfied. So you can see the constraint and all the things were matched over here. So we'll see the graphs for the project. The figure number 1 shows user demand. We have taken 10 users. It is showing demand for total 30 days in KW. Every day demands is being varied. So we are taking this demand as an input. So afterwards, we are given all the demand to the function. It is calculating the optimal selling price, and afterwards it is giving this selling price to the neural network. Neural network is printing this graph. In these two graphs, you are printed error in the first instances versus iteration of the first instance. That means we are finding the error rate. We have taken the error rate graphs over here, and again this errors function behavior and instances, wherein since our error rate is very negligible, so it will not print any error functions behavior. So in next graph we can see the average utility graph. So now this I will show you one by one. So as per the paper, if you go by this, for the first graph I will show this. This is the amount of power consumption is given. Now we'll come to the power. Yeah, this is average utility per user versus day of month, which is shown here.
average utility per user versus number of day of month is given over here. So you can see this values. It is very improvised. In base paper, it is given that ODPT with ANN is showing in green line. It is near about 1. Our value is showing average utility it is near about 1. That is more than 0.9 and less than 1 it is showing. So hence the graph is proved. Second graph, that is Edgeo profit per day. So we can see the Edgeo profit per day graph here. This is Edgeo profit of Edgeo per day graph. So I'll show that graph here. So this is the profit of Edgeo. In that figure, it is given 2.0 into 10 raised to 3 to 1.6 into 10 raised to 4. So you can see this value 1 into 10 raised to 3 into the 10 into 10 raised to 3 scales we are given. So likewise, we have taken the per day profit. It is near about 6 into 10 raised to 3, which is also optimized as per our scenario. So this is how we have taken the values. Then next is Edgeo profit ratio, that is PHI. So this is the Edgeo profit ratio PHI graph, which is ranging from 0 to 1, and it is showing the values like this Edgeo profit ratio, which is from 0 to 1. Okay, so it is printed. This graph is representing the Edgeo profit ratio (PHI) based on phi, that is versus number of days. It is shown here like that. This is also proven. Then we'll go to the next graph. This is our power utilization efficiency graph. So you can see the power utilization efficiency graph here. This is the power utilization efficiency new, and this is our outcome graph. You can see OPDT green line, which is very similar to our utilization graph. So hence this graph also satisfied. So likewise, we have printed all the graphs which were mentioned in the paper for the over provision scenario. Likewise, we will run the under provision scenario. Now this second program is for under provision. Both the programs were same, only we have change that values of CJT, AJT, DIT, YJT and XIT as per the paper. So as per the paper we have taken this value. Also selling price ST is 4.850 in the second scenario, whereas in first scenario it was different. So I'll run this function under provision scenario. Again, it will execute all the function as like previous, all the objective function, neural network, everything it will run, and it will print various results as soon as possible. So likewise, we have completed all the simulation in the MATLAB, and all the result mentioned in the base paper were proven very optimizedly and very neatly and cleanly. We have printed all the performance matrix to show all our outcome. So our system is running under provision scenario. Neural network is predicting the user demands in under provision scenario. Okay, by this way as well, our system has given the outcome. See, in the under provision scenario, our selling price is given like that, predicted demand is like this, total actual demand. We'll see this result as well in the thesis to verify the results and all. See, this is the under provision scenario. We in this, like we are taken DIT, XIT as like that. Now, as a predicted demand, our predicted demand is printed here. You can see the values of predicted demand. Afterwards, we'll see various values of the graph. See, it is like we can see the purchase amount, that is 2.857 purchase amount is there. So you will see this purchase amount here. This is purchase amount 2.857. It is similar. Then actual demand calculated by our system is 3.7340, and in the base paper it is 3.7380. it is very similar. Then our total utility provided is 9.678, and as per our calculation it is 8.6720. It is also similar. Again, four performance matters given, that is total profit. Utility is this: total profit 4.543 into e raised to 3, profit ratio that is 0.995, power utilization that is 0.6535. You can see as per the value, due to under provision scenario, power utilization efficiency and utilization utility is reduced because we are providing very under provision power to the system. So you can see the graphs as well. So as like previous, graph 1 shows the user demand, this graph shows the neural network uh, execution. So I'll see one by one. Again, this is the average utility graph, and for the under provision scenario. Again, in this, like you can see, SGO profit per day for under provision scenario. This is SGO profit ratio phi for under provision scenario. This is power utilization efficiency, which is reduced drastically due to under provision scenario. So this is how we have proven the project titled optimal pricing for the user, for the uh, grid to uh, increase the operator profit in smart grid. So this is how we have implemented this project. We had utilized the MATLAB as a front end. For a back end, we have taken the data set in the CSV format, and code is executed in product view. And whatever the result are obtained are shown and explained as like this.